base calculation, you should not show like plus or minus. You need to do it the taking off way, right? So basically, that is about floor finishes. So my question to you, anything that is involved, that is related to area, will be the same concept. As you know, for buildings, for construction, we have so many elements. Okay, so many elements. But now we won't be teaching you like every single element, every single item. Okay, so you just need to get the concept right, right? So there are students that are very concerned, especially those who are studying in Harrier Ward. They are saying that our taking off is very weak. It's not good because we only have 2 measurement paper, which is true, right? Compared to some other university or local university, we have more measurement papers, right? But then, what I want to tell you that is, you need to understand the concept right, get hold of your knowledge in your construction technology, and I think taking off for other elements should not be too much of a challenge to you. But of course, you need to understand the concept, right? So, when we talk about floor finishes, you know how to measure the area now. So if I'm measuring ceiling, is it the same?
Yes.
It's the same. Okay, the item that you are measuring is different, but it's still measuring with meter square. Okay, for example, look at this one. Okay, look at this ceiling. So there are 2 types of ceiling here. This is the fibrous plaster ceiling. Okay, this is the fibrous plaster ceiling, and the second one, the second finishes is actually the mineral fiber board suspended ceiling, right? So there are 2 elements that you need to measure. So, like I said, when you are measuring this fiber plasters, this mineral fiber board, okay, you have your description. How do you know what to write? Refer to your NRM too, right? So you will be measuring the area for this patch, right? This whole patch and this whole patch. Okay, so do you need to measure the suspender system separately? You need to check NRM. But normally, we don't measure it separately because this is a system from a supplier. When they come, they will give you the whole system. So your description will say mineral fiber board at 600 by 1.2 meter panel with all necessary aluminium tees and blah 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 and hanging wires. So your description will be in a lump sum. So you measure it meter square. Then your next question, do I need to omit the lights, fittings, and the thing, the air cons? Do you need? How do you find out? You refer to NRM too. So I'm just teaching you how to apply the concept that I've taught you to another element. So we won't be teaching you every element. So you need to understand the concept, and next time when you go to work, understand the concept first. Then you will be able to do everything. So the next thing you need to measure is that you need to measure the fibrous plaster ceiling. So by looking at this one, it looks like a border to me, right? But then, should I measure it in meter square or meter run? Should I measure in meter square or meter run? Huh? Meter Fatin. Meter run. Why? Huh?
It's not an equal rectangle square.
It's not equal, so okay. So what's the concept? The concept, remember, anything less than 600 mm width. You have learned it in the floor, for your floor. Anything less than 600 mm width, you will measure in meter run. So what you need to do is to see, is this 600 mm? Obviously, this is not 600 mm. It's more than 600 mm. So what do you measure? Measure in meter square. Because it's more than 600. Okay? So that side, is it this is more than 600? What about this side? Is it more or less than 600? So if it's more than 600, even though it's the border, it will be in meter square. So apply the concept right, okay? So then when we talk about a wall, this is actually horizontal elements, and this is vertical elements. So what about the wall? The wall, we will be doing the same thing. It's also in meter square, right? Plaster and paint. So what do you measure? You measure the length of the perimeter of the rooms multiplied by the height of the building or the story. Okay? Then you need to do all necessary omission for the windows, because these windows are big. It's not anything less than 1 meter square or 500 meter square. So this is big. You need to omit the window. Understand? So these are the things that you need to understand. Okay? So I hope that you have done your tutorial. Please email it to me. Okay? So I can actually project it out here and go through. I will pick some of it, okay, to discuss on the PowerPoint. It's so much better that everybody is looking at the same thing. Okay? So now, let's go to the other thing that we said. Center line. Today's lecture is about center line. What is center line, right? So normally when we measure, we take internally or externally or center line. I think last week I did mention about what is center line, isn't it? I did mention about what is center line. So when do we use center line? When do we use internal? So it depends on the element that we are measuring as well. So because finishes is only here, so your measurement has to be a center internal dimension, right? Have to be internal dimension. Okay? But when do we use center line? Okay? Center line means like that. Center to center. Alright? So just to let you know, the center line, you are learning, this is a concept. But the purpose of learning this center line is to actually to enable you to do the calculation for the substructure taking off. Okay, so the substructure taking off is important. Okay, so it's a different elements totally. So the concept is so it involves meter cube excavation instead of the floor finishes, which is quite straightforward, right? So this is what we call the center line. Okay, so this is, so you have a direction like north, south, east, west. I think I noticed in UK they like to put north, south, east, west. In Malaysia, we always put front or rear, and then the left and the right elevations. So I mean the concept is the same, but you need to get the north, south, east, west, west, east all correctly. So what is the center line? The center line is the total length of an element of works measured along its needle, okay, like the picture, the red dotted lines, measured as a total linear length, right? So when I'm measuring, what do you mean by measure a total linear length? Meaning I want to know the length of this wall. This wall, I will take the center to center line. Correct? Alright? So taking all corners into account, provide a quick method of measurements, avoid overs and betweens, okay, to prevent over measurement. You see, if you are measuring this one from here to here, okay, this, then from this one you will have to take from here to here, so that you don't over measure, isn't it? So sometimes you will get confused. So to make things easy, we just take center line. Alright? So, minimize mistake. Once found, a center line can be used to find multiple quantities. Sometimes it can be adjusted. So, remember what I say? Always use the the given dimension. So last week, I think Elvina and Haley, is it? They did the measurement for the floor finishes. So they are saying that I use the same method, but we have a different answer. So what is the different answer? Because Elvina measured it as 2.1, but the written dimension is 2.17. So which one to use? 2.17 or 2.1? 2.17 because it is the written dimension. So because they have done their taking off correctly, so I can spot the errors very quickly, right? So there will be a difference of the total quantity, all right? So just take note of that. So why we want to use this center line is because in some circumstances when we don't have the measurement, we can try to do the calculation based on the measurement given. Okay, so this is the symbol of center line. Okay, CL, center line, the symbol of center line. So this is the foundation, this is the wall, this is the center line. Okay, just to let you know, this is the meaning of the center line. Okay, so center line applications, foundation trench excavation. So when do we use center line? When do we use center line to do our measurement? Foundation trench excavation, concrete work in foundation, brick or block works, cavity walls, cavity fillings, DPC, backfilling to trenches, with adjustment, hardcore filling with adjustment. So basically there are a few items which is falls under substructure taking off list. This is under substructure taking off list. This basically all okay. All is part of the taking off list for the substructure work. Okay, so after center line introduction, you will go to substructure taking off. Okay, so take note. So this is a section, okay, of a foundation and the walls, right? So you can see that this is your strip foundation, and this is your walls, and this is the hardcore. What is hardcore? What is hardcore, class? You have to ask questions like that. If you don't want to ask me, fine. You need to go and find it or Google it. What is hardcore? If you don't understand what it is, it's hard for you to visualize and know what is this. What is hardcore? Why do we have hardcore? Huh? Hardcore is normally aggregate, stone aggregate, right? If you notice that you see people doing roads or construction, they will pour a certain depth of aggregates. Aggregates, you know, right? The pebbles and not pebbles. Pebbles is for small one. Aggregates, stones. Okay. On top, before they put the sand and they compare it, then they put the road or they put the concrete slab. Okay. So what's the purpose of hardcore? It's actually to strengthen and to level up the soil, okay, before you put any foundation. Because imagine if you don't put any hardcore here and you don't compact, when the soil have any movements or settlements, what will happen to your concrete floor? It will crack. Okay, settlements mean it will have movements. When you have movement, your slab will crack. So sometimes when you look at your ground slab, your apron slab, they will have that some fine lines cracks there, right? So that's what happened. Okay, so you have to fill in. So when you excavate, okay, look at this profile. Okay, so tall I cannot show. Okay, look at this profile. When you excavate, what do you excavate? Do you excavate like that? You excavate here, and then you excavate here. How do you do your work? Huh? You excavate one by one, or you actually excavate the whole trench. Yeah, so you excavate the whole trench. So this is construction technology, methodology, so that you have enough space to do work around here. But then, you need to fill it back. Alright? Okay, let's talk about this later. We are talking about center line first, okay? So, over and between. What does it mean, over and between? So this is over, and this is between, right? So if we don't use center line to center line, we will be doing our measurement, the length of this wall plus the length of this east and west, right? So that we don't overlap, right? So if I take this perimeter, okay, see, when you measure internally, it don't reflect the full length of the wall, right? Because it is lesser. So if I measure according to the external, it don't reflect as well because it is over, right? It will be longer because there will be overlapping here, this side. So the best way to measure the wall, the length of the wall, is to take the center line to the center line. Okay, can you understand this concept? Yes? So now, this is an example of a trench, right? So how do you see this plan? How do you interpret this plan? See, this is your foundation, right? This is your foundation, and this is your wall. So if you look at this elevation, you see from top, okay? For example, it's a bird eye view, right? From the top. You will see these two sides, okay? These two sides, okay? And then this one is the wall, which is this one, right? So this is the wall. Okay? Can you understand this drawing? Yes, I'm going very slowly, okay? I try my best to go very slowly, but please follow me step by step, okay? So then, calculating the center line. So here you have the one perimeter like that, and you want to calculate the center line here. So you must look at the dimension given. Sometimes they give you internal dimension, so you will do adjustment accordingly. You need to add because your center line is further in. You need to add. But if they give you to the external dimension, you need to omit, right? So understand the concept, okay? So sometimes when I teach in the lecture, I say, okay, you take this dimension, you minus the half of the foundation thickness. So everybody follow the same, even though in exam. But in the exam, I give internal dimension, they also minus. So you don't memorize the notes. You understand the notes. You need to know what is given to you. Okay? Alright? So if you look at this one, actually it's quite straightforward. You just need to take 2.1 minus half of the brick wall and times 2. Right? Because you have two sides, C and D. Right? Okay, let's look at the calculation. Step 1, calculate the total external girth. So total meaning the dimension that you have, make it quick, 2 times 2.1 both sides, 2 times 1.5 both sides. Okay? This is what you get. Alright? So remember, even though your waist calculation, you are going to do this kind of calculation, not the layman terms like a multiply, you put an X there, no. Okay? You do this. So this one you have total external girth. Girth means like the perimeter. Girth means the perimeter. Okay? So what do you need to do now to get your answer? Step 2, for each corner twice times half times the thickness of the wall is deducted from the external girth. So what does that mean? From here, okay, this is 300 dimension, right? This is 300 dimension. Look at this indication, 300. So what are you going to do? It is actually half first. We want to know what is this? A, B, C, D. Half of 300. But in some circumstances, this width might not be necessarily the same as this width. So you need to calculate properly. Look properly, read properly. So you need to take half of 300. Okay, put this aside first. Put this aside first. Okay. So this is half of the 300. Half of the 300. Okay. So for each girth, how many? Both sides, right? You need to minus both sides, isn't it?
Yes.
So you have this half, you need to minus by both sides. Okay. Okay, both sides. Then, how many you have? You have? How many do you have? You have? Four. Four corners. 1, 2, 3, 4. Okay? Understand? Half. Okay? You have 1, 2. For one line, you have 2. Right? How many corners you have? 1, 2, 3, 4. 4 corners. So you deduct 1, 2, 0, 0. Okay? So your center line will be 6 meter. Meaning the red color line here is 6 meter. This is how we do our measurement. But of course, the layman one, you can just say that if the conventional way, what we do is we take 2.1 minus 600, right? Times 2, and 1.5 minus 600 times 2, right? Layman ones, okay?
I didn't understand why how it's going.
We have 4 corners.
Now to take from each line.
Okay.
It has 2 layers, right? One up
Yeah,
and
these
down.
2 sides, yeah, correct. Okay? How to do this? Okay, so this is 300, okay? 300, 300. This is both, because the both case is 300. So it'll be 300 minus by 1 over 2, right? 1 over 2, because this is half of it, right? So each length you have 2 sides to minus, right? Each length you have 2 sides to minus. And then how many lines you have? 1, 2, 3, 4. So you multiply by 4.
That's because the O is 300 in that side also, right?
Yes.
If it is
So if it's different, for example, if this is 300 and this is 200, so what will it be? Example. Right? Okay? Understand? Okay, can you try to do this? Can you try to do this?
Four corners, 2 sides.
Try and do this as an exercise. Try and do this, Okay.